Hello friends, in this video, in this session, we are going to start with the new chapter, that is exception handling. It is very much important and very much interesting topic. We will want to learn. You will enjoy this topic, enjoy this process. So let's start with the theory part. First is, what is exception? Exception is an abnormal condition that arises in a code sequence at runtime. Whatever errors are there at compile time, that can be seen before running, and you can solve them before running itself. So whatever errors that remains after compilation at runtime, those errors are called as exceptions. In simple words, exception is a runtime error. Languages that do not support exception handling must check runtime error manually. Like any languages like C, C++ do not support exception handling. So they must check that error manually. So what is happening over there? In the cases, most of the cases when runtime error occurs, and in languages that do not support exception handling, the program crashes. So unintentionally or accidentally program crashes, which is not allowed or which is not expected. But Java introduces exception handling in object-oriented programming. When exception comes, object of that exception is created, exception object, and thrown to the method that caused the exception. So whenever exception or runtime errors occurs, object of that exception is created, like exception and exception object. Exception is the base class for all the types of exceptions, and that particular exception object is thrown to the method that caused the exception. That method may handle the exception or pass it on. That method, if it is capable or if it wants to handle that particular exception, it can handle it or pass it on to the next method. At some point, exception is caught and processed. Exception object, method 1 that handle exception, either process or forward. Method 2 that handle the exception, either process exception or forward. Method 3 that handle exception, either process or forward. Method 5 that handle exception. Method 5 is here. Finally, exception is being processed and then process is finished. So at least one exception, one method that is having that exception caught can handle that particular exception or must handle that particular exception, otherwise your program may crash. Exceptions are fundamental errors that violate the rule of or constraints of Java language. So there are 5 keywords in exception handling. Try, program statement. Program statements those you want to monitor are contained within the try block. Catch, if an exception is occurred in try, it is thrown and caught in catch block. So first of all, whatever program you want that to be checked, that it can happen, it can have some exception, you will write that particular program or piece of code into try block. Try, after that opening and closing curly braces. Then that particular program will be written, and if at runtime you are thinking about that this exception may occur, and actually if that exception is occurring, that particular exception will thrown and it will be caught into the catch block. If an exception is occurred in try, it is thrown and caught in catch block. After catching, you can handle it in relational manner. Sorry, that you can handle it in relational manner. It is dependent upon view. Throw. System generated exceptions are automatically thrown, and to manually throw an exception, use throw. So automatically thrown exceptions are not in your hands. These exceptions are called as system generated exceptions. To manually throw an exception, use throw keyword. Throws an exception. Any exception that is thrown out of the method must be specified such by throws clause. To manually throw, use throw keyword with the method, and exception that is thrown out of the method must be specified by throws clause. Finally, any code that is absolutely must be executed before a method returns is put in a finary block. Whenever an exception occurs, after the line of the error that generates the exception, it directly go to the catch block. Any subsequent lines after the exception line or exception line of code will not be executed at all. But in your code, if you want something to be executed, no matter if exception is occurring or not, then that line must be putted, or that line or block of code must be put into the finally block. No matter when exception is occurring or not, that piece of code will be executed at all. General form of exception: block of code to monitor for errors that is written in a try block. Then catch exception type 1 object, exception object. Then catch exception type 2 exception object. These are the exception types. Like there are multiple types of exception that may occur, like arithmetic exception, array index out of bound exception, null pointer exception, and so on. So what your program may contain, what type of error your program can generate, you may think upon. Like that, you will write that particular exception type name over here in catch block, and after that you will create the particular object of that class. So there are all types of exceptions, and for all types of exceptions there are exceptions classes already generated inbuilt in Java. So you just have to do what? Give the catch block for each and every type of exception in your catch block. And finally, block of code to be executed before try block ends. Okay, so this line of code, whatever you will write here, you may write here addition, subtraction, anything you are write here. Like if you are opening a file and there some error is generated at runtime, but you want to close that file handle or file object. So what you will do, you will use the file object dot close. So it will close the particular file. So this type of code must be executed before the try will run or try will end. You have to write it down into finally block. Then exception types. The base class of all the exceptions is throwable. Then there are two classes, exception and error. Exception is the base class for all the types of exception. Exception programs should catch or create own custom exceptions. And runtime exceptions, division by zero, and invalid array indexing. This type of exceptions are runtime exceptions. Errors. Errors having to do with the runtime environment itself, like stack overflow. So these type of error are very much tricky or very much difficult to handle. Exception can be handled, and the error that cannot be handled, it is written in the error class. What if I do not handle exception? Okay, I don't know about exception. Don't know how to write try catch, or I don't want to handle that particular exception. What will happen with my code? We will see. Class exception 0. Public static void main in that D and 42 into D. This is the division by 0 error. Okay, you know that particularly, but you are not handling that particular exception. When we divide by 0, Java runtime system constructs a new exception object and then throws this exception. So Java runtime system will automatically create or construct a new exception object and then throws this exception. When an exception is thrown, it must be caught by exception handler and dealt with immediately. Okay. Since we have not supplied any exception handler, Java runtime system sends this to default handler. So what default handler will do? Default handler prints the stack trace, or in short, it will do system.out.println and terminates the program. So output of above code will be java.lang arithmetic exception divided by 0 at exception 0 main, exception 0 java, and 4. This line number 4 is having error. Line number 1, then 2, 3, 4, like this. And default handler prints the stack trace, and it is a responsibility of default handler to handle this, because we have not provided any catch block. Okay, we have not provided any try block, or we have not provided any catch block. So for this, it is a responsibility of default handler to print this, and after reading this, your program will end. So your program actually crashes, but actually it is not, because default handler has printed this message. Now, last example was without try catch. Now we will see with try catch. Most of the times you need to handle the exception yourself. You know that your program may generate error. So it is your responsibility to put your code in try and catch block. Whatever piece of code you think that this may generate error at runtime, you will put that particular code in try block, and your catch block will catch that particular exception. Until now, we have not seen or we have not introduced exception handling. But it is a good practice. I recommend you whenever you are writing any program, since Java is supporting exception handling, whenever you are writing any program in Java, try to write it with try and catch. When you will build real life Java, real life applications, real world applications you will generate. In that case, if you will try or if you will practice to write code with try within try and catch block, any code that you will write under the class, just write try and put all the type of code, all the piece of code into the try block. After that, put the catch block. In this case, what will happen, I will tell you. If accidentally, unintentionally, if any error will occur at runtime, what will happen? It will be caught in your catch block, and your time will be saved in future. If accidentally at runtime you are writing a program without try catch, any program, and while runtime you are getting some exception, now you are shocked, and you are trying to write you are trying to read all your code from line 1 to line 50. It is okay for 50 line of code, 50 lines of code. When you are trying to read all the line of code, which is very big one, like 10,000 lines of code, how many lines you will find out? How many lines you will check? 10,000 lines. For 10,000 lines, you may require 2 to 3 hours to check whether this exception is occurring. Okay, but if you are writing all your code, all your stuff into try block, and then you are writing a catch block, that catch block will catch that particular exception and give you which type of error is occurring at which place, and you can handle that particular exception very much efficiently. And also in the catch block, you can also specify the exception object, and then you can print the complete object details. That object details will give you the complete description of the exception, so that it will be easy for you to handle that particular exception. Okay, most of the times you need to handle the exception by yourself. This allows you to fix the error and prevents the program from automatically terminating. Automatically terminating means it's crashing, but actually it is not. It is crashing with the message that, like in this example we seen, java.lang arithmetic exception division by 0. After this line, the program will not execute. This is called as crashing or terminating of your program. So this can be avoided with the using of try and catch block. How to achieve this try catch block? Simply enclose the code you want to monitor in try block. Immediately following the try block, include a catch clause that specifies the exception type that you want to catch. Now we will see the example. Here is the main integer d comma a. Try will monitor d is equal to 0, 42 into d. This will not be printed. Whatever you are writing after the line of code that may generate the exception, it will not be executed. Maybe it is 1 line, 2 lines, or any number of lines. After exception is caught, or whatever is written will not be executed at all, because this will give the control to the catch block here. Okay, so it will come here and it will match. If it is arithmetic exception, yes. If it is file not found exception, yes. If it is division by 0 exception, yes, like this. Okay, then after this it is matching with arithmetic exception, it will print division by 0, and after that, after catch statement is written over here. So output division by 0 after catch statement. Once an exception is thrown, program control transfers out of try block into the catch block. Once an exception is thrown, means what? Once an exception is given, program control transfers out of try block immediately to the catch block. Catch is not called, so the execution never returns. Catch is not called implicitly. Catch is not called explicitly. It is automatically given control to the catch block from the try block statement, so execution will not return. What is this call? When you are calling method, suppose for example in your main function, show method you are calling object dot show method, so you are implicitly calling, okay, then you are, after you are calling that method, you are directly calling, writing a statement to call that particular method. After that method execution finishes, the control will return to the same statement, calling statement, after the calling statement. But in this case catch is not called, okay, so it is automatically given control because of any error is occurred. So in that case execution will not or will never return to the try block from a catch block. So in this case this will not be printed, is never executed. A little bit extra on try catch. Now try and catch forms a unit. Scope of catch block catch clause is restricted to those statements specified by immediately preceding catch statement. Scope of catch means what? From where to where this catch is valid is restricted to those statements specified by the immediately preceding try statement. A catch statement cannot catch an exception thrown by other try statement, except in the case of nested try. So, immediately try and catch are written nearby. So, in that case, they can be catched, that lines of code or that error can be caught in a catch block from the immediately preceding try statement. But whatever is written before that try or other than that particular immediately preceding try will not be caught into that particular try catch statement. Try statements must be surrounded by curly braces, as you cannot have single statement in try block. Okay, so it is compulsory, you have to note it down, this line: try statements must be surrounded by curly braces, as you cannot have single statement in try block. Description of exception. Throwable overrides toString method defined by object so that it returns a string containing description of a exception. ToString method will do what? It will detail you the description of the exception. To print this by yourself, simply pass the exception to println. Okay. So throwable is a class. It overrides the toString method by default so that it has a string containing description of the exception. But if you want to print this by yourself, what you want to do is just pass the exception object to the println. It will print the detailed description of the exception. Now system.out.println exception E and A is equal to 0, set A to 0 and continue. This will help when you are experimenting with the exceptions or debugging. Now multiple catch clauses. In some cases, more than one exception could be raised by a single piece of code. Okay, so this particular piece of code may generate multiple types of exception at the same time. So there are multiple catch clauses you can write down. In try, you will write piece of code that is needed to be modified, then catch clause with exception type 1, catch clause with exception type 2, catch clause with exception type n. As number of exception type as you need, you can write down. When an exception is thrown, each statement is inspected in order and the first one whose type matches that with the exception is executed. If you are writing multiple types of exception, your exception will be matched or compared with the type of exception of the catch block. Okay, and with that particular catch block, after it is written, for each and every line of code it will check, and whatever is matching with the type of exception specified and the actual exception that is occurred, after that catch clause will be executed. After one catch is executed, others are bypassed and execution continues after the try catch block. So others, whatever catch blocks are remaining up to catch block n, all others are uh, bypassed, and then after catch try catch block, whatever is written, it will be executed. Now, multi-catch example is here. Public static void main. Now, a integer a is equal to args dot length. Okay. So now a is equal to a. Now how many arguments length? How many number of arguments are there? We are trying to print. Then a is equal to a. Now 42 divided by a. If there are zero number of arguments, this will be division by zero error. Okay. Then C, a array is created with one element, and at the position of C is 42, I am trying to write 99. Since C is having only one element, its capacity or length is only for only one element, it will not allow me to write the 42 index element. But still I am trying to write down, and I am writing it inside try block. Whatever is written inside try block will be monitored and caught into the catch block. Then catch arithmetic exception e divided by 0 and array index out of bounds. These two type of exceptions can occur. So I am writing over here two types of exceptions, divided by 0 and array index out of bounds. Now here, if I do not pass while execution any number of arguments, division by 0 error will occur, and after that this error may occur. Okay, if this error is occurring, if after this it will directly go to the catch block. But if I am passing here one or two number of arguments, this line will be executed, and this error will be caught. Array index out of bound exception. If we pass it as 0, it causes divided by 0, and if it is larger than 0, program still causes array index out of bound because C has length 1. Output in both ways, a is equal to 0 divided by 0 and a is equal to 1, array index out of bounds exception. Now, some points are there to remember. When you use multiple catch statement, exception subclasses must come before any of their superclasses. Multiple catch statements means exception lines, one exception, catch, one exception, then another exception, then another exception, and so on up to exception n. Okay, multiple catch blocks. In that case, exception subclasses must come before its superclasses, so that the exact error or exact exception may be found. Because a catch statement that uses a superclass which catch exception of that type plus any of its subclass. So you will not find any particular error that your program is having. You will not get any particular description of your type because of that. So for that, any subclasses will appear must appear before any of their superclass. The subclass would never be reached if it comes after its superclass, because superclass exception class will catch all the exceptions of its all subclasses. Subclass would never be reached in that case. And in Java, unreachable code is an error. If you are writing, suppose exception object. Exception is a head class or superclass of all type of exceptions. And after that you are writing arithmetic exception or divided by 0 or find not found exception like this. That next exception after exception class will not be caught or will not never be reached. In that case, unreachable code will occur, and this is called as any type of error, and this will give you compile time error. Now we will see the throw. It is possible for your program to throw an exception explicitly using the throw statement. So what is the syntax? Throw, throwable instance. Okay, if it is not handling, it can throw it. Throwable instance must be of type throwable class or a subclass of throwable class. Simple types such as int or char, as well as non-throwable classes such as string and objects, cannot be used as exceptions. Okay. You cannot throw int or char as well as non-throwable classes, string and objects cannot be thrown. So they must be object of type either of throwable or a subclass, any subclass of throwable. There are two ways you can obtain throwable object: using parameter into a catch clause and creating with one with a new operator. The flow of execution stops immediately after the throw statement. Any subsequent statements are not executed. The nearest enclosing try block is inspected to see if it has catch statement that matches the type of exception. Nearest enclosing try block. Nearest. When your exception is thrown, nearest try block is found out and it is monitored to see if it is having a catch statement that matches the type of exception. If it does not find a match, control is transferred to that particular statement. If does find a match, control is transferred. If it is not, then the next enclosing try statement is found out and monitored, and so on. If no matching catch is found, then the default exception handler halts the program and terminates the program and prints the stack trace, and your program is finished. Then nested try statements. A try statement can be inside a block of another try. Each time a try statement is entered, the context of that exception is pushed on the stack. So when one try statement, if there are multiple try statements, one inside the another, what will happen if each time that particular try is given? For nested try or non-nested tries, I'm telling you about, every time, for each and every try statement, context of that exception is pushed onto the stack. And what is the strategy? First in, last out. Okay. If an inner try statement does not have a catch handler for a particular exception, stack is unwound and the next try statement's catch handler are inspected for a match. This continues until one of the catch statements succeeds or until all of the next try statements are exhausted. Okay, all of the catch statements will be monitored for to see if that particular error or exception can be caught inside that particular catch statement. If there are inner try statements and if in inner try there is no catch block present to handle that particular exception, that stack is unwound and next try statements catch handlers are inspected for a match. That is, outer catch statement is monitored, and until all of the catch statements succeeds, until one of the catch statements succeeds, and until the error and exception is found and caught into particular catch statement, or until all of the nested try statements are exhausted, until all the catch statement checking is finished. Then throws keyword. If a method does not handle exception, it must specify this so that callers of the method can guard themselves against that exception. Okay, the caller will guard themselves, that they will know that this method will not handle my exception. You do this by including throws clause, throws list of type exception that a method might throw. Okay, this is necessary for all exceptions except error or runtime exception or any other subclasses. Okay, throws have types of exception except error class that we have seen in a diagram, or runtime exception or any of their subclasses. If they do not list so, compile time error with result. Type method name parameter list throws exception list. Okay, and body of the method. Exception list means which type of exception it is throwing, like array index out of bound exception, comma, file not found exception, comma, null pointer exception, comma, etc. etc. Exception list is a comma separated list of exceptions that a method can throw. Then last one is finally, when an exception is thrown, execution in a method takes non-linear path. Okay, non-linear means if particular exception has been occurred, then after that any line of code will not be executed at all. Finally creates a block of code that will be executed after a try catch block has completed and before the code following try catch block. Finally block will execute whether or not exception is thrown. No matter that exception is thrown or catch or caught, finally block will execute means execute. If an exception is thrown, the finally block will execute even if no catch statement matches the exception. Okay. Anytime a method is about to return the caller from inside a try catch block via an caught exception on an explicit return statement, finally is also executed just before the method returns. Okay. So finally, always guarantee you that your statement will be executed. Okay. If you are try catch having uncaught exception, you have not specified any particular catch block for that particular exception, or you are explicitly returning the return keyword like RETURN and then semicolon, then also finally will be executed. So finally is a guaranteed block of code for the try catch block. Okay. This can be useful for enclosing file handle and freeing up any other resources that might have been allocated at the beginning of the method. That I have given you the example in previous slide that you may want to close the file handle with the intent of disposing before returning. Okay, when you are when we will seeing the file handling, in that case we will need to close the file. After the operation is done, we require to close the file. Finally is optional. If you want any statement to be executed at all, finally will be written. However, each try statement requires at least one catch or finally clause. Okay, if you are writing try, there must be at least one try, one catch, or we try at least one finally. If catch is not present, you can give finally. Otherwise, catch is present, finally is optional. Unchecked exceptions. Inside standard package Java Java defines several exception classes. The most general of these exceptions are subclasses of the standard type runtime exception. These exceptions need not be included. Runtime exceptions need not be included in any method throws list. Okay. Most general of this exception from java.lang are subclasses of standard type runtime exception. These are called unchecked exceptions because the compiler does not check to see if a method handles or throws this exception. Okay, it is compiler's responsibility to check, but if there are unchecked exceptions from runtime exception class, it will not check to see if method is handling or throwing the exception. The unchecked exceptions defined in java.lang are given here. Arithmetic exception, divide by 0, array index out of bounds, array index out of bound, array store exception, assignment to an array element of an incompatible type. You are storing like boolean into integer like this. Class cast exception, invalid casting, enum constant not present exception, attempt is made to use an undefined enumeration value. Illegal argument exception, illegal argument used to invoke the method. Okay, so argument is integer, you are passing float like this, or argument is integer, you are passing string. Illegal monitor state exception, illegal monitor operations such as waiting on an unlocked thread. We will see in that multi-threading chapter, upcoming chapter. Illegal state exception, environment or application is in incorrect state. Illegal thread state exception, requested operation not compatible with current thread state. Okay, index out of bounds exception, some type of index is out of bounds. Negative array size, array created with negative size which is not allowed. Null pointer exception, invalid use of null reference. Number format exception, invalid conversion of a string to a numeric format. Security exception, attempt to violate the security. String index out of bounds, attempt to index outside the bounds of a string. Type not present exception, type not found, unsupported operation exception, unsupported operations was encountered. Then checked exception. Below table is those exceptions defined by java.lang that must be included, and in a methods throws list if that method can generate one of these exceptions and does not handle it itself. These are called as checked exceptions. Java defines several types of exceptions that relate to various class libraries. Checked exceptions, class not found exception, class is not found. Clone not supported exception, attempt to clone an object that does not implement the clonable interface. Okay, clone an object that does not implement the clonable interface. It must implement this interface. Illegal access exception, access to class is denied. Instantiation exception, attempt to create an object of an abstract class or interface. Interrupted exception, one thread has been interrupted by another thread. No such field exception, a requested field does not exist. No such method exception, a requested method does not exist. Creating your own exception subclasses. You can create your own exception types to handle situations specific for your application. For this, just define a subclass of exception, which is of course a subclass of throwable. Okay, your subclasses don't need to actually implement anything. It is their existence in a type system that allows you to use them as exceptions. The exception class does not define any methods of its own. It does of course inherit those methods provided by throwable. Exception is from throwable. So whatever you are writing, that exception class inherit all those methods from the throwable class. All exceptions, including those you create, have the methods defined by the throwable available to them. Okay, when you are extending the throwable class, then all the methods we will have all the methods of throwable class to be used by your own code. Methods by throwable. Throwable fill-in stack trace returns a throwable object that contains a completed stack trace. This object can be rethrown. Throwable getCause returns the exception that underlies the current exception. If there is no underlying exception, null is returned. Okay. String get localized message returns a localized description of the exception. String get message returns a description of the exception. Stack trace element gets stack trace returns an array that contains the stack trace one element at a time as an array of stack trace elements. Okay, returns an array that contains the stack trace one element at a time as an array of stack trace elements. Okay, all the elements stack trace will be written in this array and you will get one by one using the index. The method at the top of the stack is the last method called before the exception was thrown. Okay, because stack strategy is first in last out. So first method called in the it will go into the stack trace elements first index, that is bottom. After that, next method call will be put, then next method call will be put, and in the last you will have the last method called in that case. This method is found in the first element of the array. The stack trace element class gives your program access to information about each element in the trace, such as its method name. Okay, including method name, it will give you complete information. Throwable init cause, throwable cause exception. Associate cause exception with the invoking exception as a cause of invoking exception. Returns a reference to the exception. Then print stack trace displays the track trace as we have seen. Print stack trace, print stream sends the stack trace to the specified stream. Print stack trace void print stack trace. Print writer stream sends the stack trace to the specified stream. Then void set stack trace element sets the stack trace to the elements passed in the element. This method is for specialized applications, not normal use. Not for normal use. Okay. So set stack trace is used for specialized application. And string to string returns a string object containing a description of the exception. This method is called by println when outputting a throwable object. Now, I am creating my custom exception. This exception extend exception integer detail. It's a parameterized constructor. Detail is initialized to a. Then toString exception detail. Exception demo. Then compute method throws my exception called compute with a. If a is less than a is greater than 10, throw new my exception a normal exit. In that, if a is less than 10, it will be printed with normal exit. Otherwise, after throw, it will go to the catch exception. Then public static void main. Compute 1, compute 20. System.out.println caught. So 1 is greater than 10. No. Normal exit will be printed. 20 is greater than 10. Yes. Then normal exit will not be printed. Exception will be thrown. And in this case, it will be caught and printed. Called compute 1 normal exit and called compute 20 caught my exception 20. Okay. Chain exceptions. The new feature has been incorporated from JDK 1.4. Chain exception. The chain exception feature allows you to associate another exception with an exception. Okay. The second exception describes the cause of the first exception. Though those are both related. For example, imagine a situation in which method throws an arithmetic exception because of attempt to divide by 0. So you are trying to divide by 0, and because of it arithmetic exception has been occurred. But the actual cause of problem was that input output error occurred which caused the divisor to set up improperly. Okay. So actual cause of arithmetic exception was input output error. Although the method must certainly throw an arithmetic exception, since that is the error that occurred, you might also want to let the calling code know that the underlying cause was IO error. Okay. So calling code should understand that because of what that arithmetic exception has been occurred. Chain exceptions let you handle this and any other situation in which layers of exception exist. Okay. To allow chain exceptions, two constructor, two methods were added to throwable. Throwable with throwable cause exception, throwable string message, throwable cause exception. In the first form, cause exception is the exception that causes the current exception, and in that its cause exception is underlying reason because of which this exception has occurred. The second form allows you to specify a description at the same time that you specify the cause exception. Okay, why this has been occurred, what is the reason, displaying the description of the exception. These two constructors have also been added to the error exception and runtime exception classes. The chain exception methods added to the throwable are getCause and initCause. These methods are shown in table and are repeated here for the sake of discussion. Throwable getCause, throwable initCause, throwable cause of exception. The getCause method returns the exception that underlies the current exception. If there is no underlying exception, null is returned. The initCause method associates cause exception with the invoking exception and returns reference to the exception. Thus you can associate a cause with an exception after the exception has been created. Cause exception can be set only once. Thus you can call initCause only once for each exception object. Okay. InitCause associate cause exception with the invoking exception and returns a reference to the exception. Okay. And you can associate cause with the exception after the exception has been created, but cause exception can be set only once. If the cause exception was set by constructor, then you can't set it again using initCause, because the rule is that cause exception can be set only once. In general, initCause is used to set a cause for legacy exception classes that do not support the two additional constructors described later. Now, chain exception demo procedure, null pointer exception E, new null pointer exception top layer, add a cause. E.initCause new arithmetic exception cause throw E. Okay, so what is the top layer? Null pointer exception. But what is the initial cause? Arithmetic exception. Because of this arithmetic exception, null pointer exception has been occurred, and we are throwing that E. Then in try, I call demo procedure, and catch null pointer exception. Display top level exception caught and display cause exception original cause e dot get cause. The output is java.lang null pointer exception top layer and original error is arithmetic exception. The top level exception is null pointer exception. To it is added the cause exception arithmetic exception. When the exception is thrown out of demo procedure, it is caught by main. Here the top level exception it is displayed, followed by the underlying exception which is obtained by calling get clause. Now points to remember, chain exceptions can be carried on whatever depth is necessary. Okay, one exception is occurred, but the underlying exception is that for that exception is exception 2. Underlying cause of that two exceptions is exception 3 and so on. So whatever depth is required, you can give it. Thus the exception cause exception can itself have a cause. Be aware that overly long chains of exceptions may indicate poor design of programming. Chain exceptions are not something that every program will need. However, in cases in which knowledge of an underlying cause is useful, they offer an elegant solution. Okay, not every time it is illegal, but try to put the chains of exception as small as possible because it will show that you are not properly designing or you are not properly writing your program. Okay. Now using exceptions. Exception handling provides a powerful mechanism for controlling complex programs that have many dynamic runtime characteristics. Try, throw, and catch. You can think of it as clean ways to handle errors and unusual boundary conditions in your programming logic. Okay. In try, you can write a code. Using throw, you can throw the error or exception, and using catch, you can catch the exception. Unlike some other languages in which error return codes are used to indicate failure, Java uses exception. Okay. When a method can fail, have it throw an exception. This is a cleaner way to handle failure modes. Whenever you think upon like this line of code can generate runtime error, just give it a throw keyword and throw an exception and let it be handled by somebody else, like some other method or a main method. One last point. Java's exception handling statements should not be considered a general mechanism for non-local branching. If you do so, it will confuse your code and make it hard to maintain. Okay. Those exception handling statements cannot be considered or should not be considered a general mechanism for non-local branching. Now, use exceptions only for exceptional conditions. Someday, if you are unlucky, you may stumble across a piece of code that looks something like this. Integer I is equal to 0 while true, range of I++ dot clean, and you are catching an index out of bound exception. What does this code do? It is not at all obvious from inspection, that's the reason not enough not to use it. Okay. It turns out to be horribly ill-convinced idiom for the looping through the elements of the array. Infinite loop terminates by throwing, catching, and ignoring an array index of exception when it attempts to access the first array element outside the bounds of the array. You are writing it while true. This is the infinite loop generated. Okay. You are putting I, incrementing and climbing. Putting I, incrementing and climbing unless and until while true. So this is giving you infinite loop. It is supposed to be equivalent to the standard idiom for looping through an array which is instantly recognizable to any Java program. For mountain m range m dot climb. So why should anyone use the exception-based loop in preference to the tried and true? It's a misguided attempt to improve performance based on the faulty reasoning that since the virtual machine checks the bounds of all array accesses, the normal loop termination test hidden by the compiler but still present in the for each loop is redundant and should be avoided. 3 reasons we will see, 3 things. Exceptions are designed for exceptional circumstances. There is a little incentive for the JVM Java Virtual Machine implementers to make them as fast as explicit tests. Placing code inside a try-catch block inhibits certain optimizations that modern JVM implementations might otherwise perform. The standard idiom for looping through array does not necessarily result in redundant checks. Modern Java virtual machine implementation optimize them away. Not only the exception-based loop obfuscate the purpose of the code and reduce its performance, but it's not guaranteed to work. In the presence of unrelated bug, the loop can fail silently and mask the bug, greatly complicating the debugging process. Suppose the computation in the body of loop invokes a method that performs an out-of-bounds access to some unrelated array. If a reasonable loop idiom were used, the bug would generate uncaught exception, resulting immediate thread termination with a full stack press. If the misguided exception-based loop were used, the bug-related exception would be caught and misinterpreted as a normal loop termination. The moral of story is exceptions are, as their name implies, to be used only for exceptional conditions. They should never be used for ordinary control flow. Ordinary means then your code is not going to generate any type of error. Try to avoid the try catch. But most of the times it is better you are writing for the try catch for the base class, that is exception, as I have already told you. But if you think that your code is very small for 4 to 5 lines of code and if this may not generate, you are guaranteed that it will not generate any type of exception. In that case you cannot write the try catch. Okay, but for the long code that may generate error, like 10,000 15,000 lines of code you are writing, and after that in any case if you are finding any error or exception at runtime, it will be tedious for you to find out that exception in which line it is occurring. In that case you are afraid of that exception might occur. So it is a good practice. In that case you can write down the try and catch block. More generally, you should use standard easily recognizable idioms in preference to overlay clever techniques that purport to offer better performance. Even if the performance advantage is there, it may not remain in the face of steadily improving platform implementations. The subtle bugs and maintenance headaches that come from overly cleaner techniques, however, are sure to remain. Now, these are some exceptions we have already seen, but we will see it again. Illegal argument exception, non-null parameter value is inappropriate. Illegal state exception, object state is inappropriate for method invocation. Null pointer exception, parameter value is null, will prohibited. Index out of bound exception, index parameter value is out of range. Concurrent modification exception, concurrent modification of an object has been detected where it is prohibited. Unsupported operation exception, object does not support a method. Okay. These are the references I have used to generate this PPT. Complete reference of Java, Herbal Shield and Effective Java, Joshua Bloch. And these are the attribution. Many thanks for this attribution. Icons I have used in my PPT. All the icons, surprised icon, happy icons and so on. This is the attribution links. Thankful for them. These are links. You can go through it. Thank you so much. So this way we have seen the exception handling theory part. We have completed the exception handling theory part. Now we will see in the next session exception handling practical. So meet you in the next session. Thank you so much.